Hello YouTube. Let's see if we can get this focused up a little bit more. Okay, this is the update for my build version on JA2NKD's RF analyzer schematic. All kudos to Rusan Matsuru. He's most excellent. Right, what we've got is a 5-volt regulator, 7805, 7809. Tapped out. All the red lines are power. The Arduino Nano. This is a 88, brain cells gone dead. AD9851. Now this is a friend of mine's and it's a dead unit. It's just purely up here for me to build because I have a 9850 to go in here. This is the low pass filter. Cut-offs around about 65 megahertz. I have run it through my signal generator there and the scope, and away we go. This is the AD8307. See if I can get a little bit better here. Decoupled input, 50 ohms. This is where I had trouble when I built the other one, which is just above me by here. It's, see if I can get the glare off that a little bit. This particular one has to float. It's not grounded. That's why I was having so much trouble. If you can see on the schematic here, right, input, ground. There is no ground as such on this unit. It's decoupled. When it's measuring, it does not require a ground. The ground is for the purely on a 5-volt unit anyway. Okay, everything else on there is as per the unit. The only thing I haven't done is added the extra filtering on the 5-volt regs because I intend to run this on a 12-volt unit anyway. These are the header pins for the remote connections out to the switches and such like. I know there's only 5 connections, but there's 4 actually, but I've added the full row there just in case I need them. There are 2 on the other side here for the encoder, and I'll pick up a ground somewhere, whatever. I'll put a header pin on the ground because I happen inadvertently used the ground pin here. I don't think it'll focus, but you've got the reset ground and then D2 and D3. D2 and D3 are used for the encoder. It's a grey encoder. It's not a KY040. It's not that one. You have to use a grey encoder for it. There are only 3 terminals. We'll put this up on the schematic when I put it on the computer and show the code. Again, this is not my code. This is Matsuru's encoder. This is that jumper out to the TFT. This cable is going to be remade. I've got some 2-point headers, some 8-pin 2-point headers in. Pull this out for a second. 1 second. Okay. Now this is my version. I found this on YouTube while doing some research. I could not get the CD4050 that he wanted to work. My inexperience, I'm purely a hobbyist. This is for my own benefit. This is built my way. Alright, everything on here is point to point wired as such, using either component or some jumper wires. This is the 5-volt reference wire. This is it's supposed to be 2.5 volts, but I haven't measured it exactly yet. But there's a voltage divider here off the 5-volt line and ground picked up, fed in to act as a reference. I think there's somewhere on the code that I can alter this, but this particular one, if you need to alter it, change this resistor here on the other side of the ground, give you a something like these are 1K resistors, all apart from this one here. Let me get him right. That one there is the 24 ohm resistor to the TFT, which is picked up there on pin 8. And that's where I am at the moment. As such, this is complete. There's nothing else to do on this board now apart from wiring the external components. So we'll leave it at that for the moment, and I will have a walk through the Matsuda's code, and which is a long code. It's a very, very long code, and I'll see if I can give a practical demonstration of how this thing works as well. Okay, there you are. Slightly longer video. I haven't been very well. I've not had the wife very well. We've had all sorts of problems at the QDH here, so there we go. There you go. Have a nice day. Bye-bye.